We're live. All right, we're going to talk today about graphing logarithms. They do take a little bit of time, so we're only going to do one, but this is a pretty complex logarithm to graph, and if you can do this, you can do any of the ones that we ask you to. So the first thing you want to see when you look at a logarithm is what is the base and what does that parent function look like. So all of this, before this garbage that translated it, started with just y equals log base 3 of x. Right, that's where it came from, that's the parent function. So really, what I think about is 3 to the y equals x, if we go exponential. So my parent table, this is where all my thought process comes from. It almost works backwards a little bit. I want this to be convenient. If y was -1, then x should be a 1/3. If y was a 0, then x should be 1. And if y was a 1, x should be 3. With these 3 points, you really can see the curve of any kind of logarithm function. But notice, that's my starting thought. I'm not even going to put it on the graph. Next, I have to think, is it being stretched or compressed? I have an a value of 2, which means my y values are going to need a better marker. They're all going to have to be multiplied by 2. So my new points with the stretch of 2 will be 1/3 2, -2, no tally, 1 0, and 3 2. Full disclosure, this is still not my graph. This is going to help me find my graph. These are the points of the parent function that's stretched by 2. Watch how nice this is. I go to 1/3 -2. Pretty accurate. 1 0. And then 3 2. Now again, I'm not drawing this curve. I'm not going to draw this curve. Because this is where my points would be if I took the parent function log base 3 and stretched it. But notice, you have some other transformations going on here. I already mentioned this is going to be stretched by 2. We've already accounted for that. But it's also moving right 1 and then up 3. So look how easy this is. Take each point, go right 1 and up 3. Right 1, up 3. Right 1, up 3. I can count 1, 2, yeah, I can. Right 1, up 3. Now, this validates everything else I just thought about. Because if you were looking from the beginning, my vertical asymptote should have been x equals 1. It is. I can draw my curve, and like a gentleman, the asymptote you approach but do not touch, and you're finished. Easy way to go from the parent function, see the stretch, I plot those points, and then move using my transformation.